Hello, everyone. My name is Neal Ford, and I am joined today with my frequent collaborator and co-author, Mark Richards.
Hey, everyone. My name is Mark Richards.
And we are here today to talk primarily about, but we can never restrict ourselves to one set of topics, but primarily about our most recent book, Software Architecture, The Hard Parts. So a lot of people ask us, is Software Architecture, The Hard Parts, was it a part one, part two situation with our previous book, Fundamentals of Software Architecture? And it turns out it was not at all. When we were writing the Fundamentals book, we kept bumping into these really difficult problems. And as we started diving into them, we started saying, oh, no, that's too hard. And at one point, Mark sort of jokingly said, what?
Well, I said, we had so much additional material. I said, this really is all the hard parts. And we should have that as the title of our next book. And sure enough, it became the title of our next book.
Well, and so Architecture, The Hard Parts became sort of our get out of jail free card for really complex problems. It's like, okay, well, let's put that over in the hard parts pile. And as we were writing that book, that pile got bigger and bigger and bigger. And when we published the Fundamentals book, we started thinking, well, okay, what next book should we write? We looked at that giant pile of difficult problems and thought, okay, well, let's poke around and see what's making those things so difficult. And we quickly arrived at, there were a lot of difficult things there, but it seemed like the lion's share of the difficult things had to do with distributed architectures like microservices, which is the common cool kid architecture right now. But there are a lot of challenges inherent in distributed architectures. And as we started poking around in those problems, we discovered that a lot of it came down to coupling and actually started separating the concept of coupling into two different kinds of coupling.
Yes. But as a matter of fact, the interesting thing is, what would you think? I bet it was almost close to 7 years, all total, from the first book that we wrote. Neal and I were together, and Neal said, it's a shame that there's not a great comprehensive book about software architecture that kind of covers all of the techniques, the technologies, and also the soft skills piece. And both Neal and I, well, Neal, I think I've known you now for almost 16 years. I think almost 18 years.
A long time.
It's been a very long time. And actually, we met at a conference that in the United States that was kind of like a traveling roadshow. We would go to cities twice a month and give all of our sessions, our material. And it turns out that Neal and I were two of the only speakers who actually touched on architecture talks as opposed to these really deep technology ones. Now, we also did a lot of deep technology talks, but we also talked about software architecture. And that started to grow. And so Neal and I started to collaborate a little more. And then finally, about 7 years before the Fundamentals book was published, Neal came up with this idea. He said, we ought to do a video. We ought to put some material together and start getting this stuff out and collected. And that's what ended up being the Fundamentals book. But my point of all that was we both had so much fun writing the fundamentals of software architecture. And it worked so well with the way we both kind of came at architecture with a different perspective that we both knew, okay, we got to write another book. But we weren't sure what it was. And that's how kind of all that material that we started to say, we can't put that in the fundamentals book, started to evolve into the hard parts. But Neal came up with a fantastic way of organizing that material. And that is how our book ended up being structured. Do you want to actually talk about the concepts that you had? This rubber band.
Well, he actually touched on one of the things that we also sort of stumbled upon but have taken great advantage of, which is this idea of iterating on design in both architecture but on IP as well. Because when we started talking about software architecture, it was just too much of it. But as you teach training classes, as you do more writing about it, as you do videos, you start refining and realize, what really needs to be there. And that's really this kind of iterative approach to IP. And we realized that same approach would work with the hard parts material, even though there was less sort of inherent structure in it. And so as soon as we had this giant pile of examples, we thought we need some way to unify this. And one of the first things we did was a 2-day workshop at one of the O'Reilly Software Architecture conferences. And we needed some way to kind of organize this material. And many years ago, I wrote a book called Presentation Patterns. And one of the patterns in there we called the triad pattern, which is when you're in doubt about how to organize stuff, organize it in threes, because people, think in chunks of threes and three main ideas away from a talk. So, and there's this famous quote by, I think it's Larry Constantine, about, it's basically this idea that it seems like there's this force in software architecture. We keep breaking things down into smaller and smaller pieces until we get pieces that are so small they're not useful anymore. And then we have to start gluing them back together to make useful work. And so I thought, well, it seems like there's this constant pendulum swing in software architecture of, we got to break things down more. But then they're broken down. It's like, we got to put them back together. And so this idea of pulling things apart and then putting them back together. Part 1 was pulling things apart. Part 2 was putting things back together. And then part 3 was with simple pieces and simple patterns. So trying to embrace that idea of simplicity. And then at some point, after iterating on that a few times, we realized that the third part wasn't really needed, that what we really needed was the first 2 parts. And that became actually the macro structure of our book. And that really nicely fell into sort of part 1, pulling things apart, was about how static coupling works, how things are wired together in software architecture. And part 2 was about dynamic coupling, which is once you've got these things, how do they talk to one another, which turned out to be a really, really difficult, interesting problem. But the interesting side effect of that was we started with this kind of 3-part thing and then ended up with this 2-part thing. And then we sort of forgot that existed. And we just wrote. And we wrote the natural material for part 1 and part 2 and got it all together. And it was during the copy editing phase that I noticed that out of a 450-page book, part 2 started on page, I think it was 221. So it was almost exactly the midway point. That was not intentional at all, but we ended up writing almost exactly equal parts around the kind of static coupling wiring versus dynamic coupling.
And that was amazing how that kind of happened like that. But this was something Neal originally kind of proposed about this pulling things apart, putting them back together, which was so clever because if you think about decomposing systems into a level of modularity, breaking those things apart, Neal just hit on this play of words of putting them back together. It's like, wait, what do you mean? We just spent all this effort tearing apart and breaking apart our systems. What do you mean? Now you want us to put them back together? And it's like, well, how are you communicating? What do those contracts look like? How are you doing distributed transactions? How are you accessing data you no longer own? How are you doing distributed workflows and transactional sagas? And all of a sudden you realize, oh, right. You have to interconnect everything, which is just such a clever way of saying you got to put things back together. But you know what, Neal? You know what would be really interesting to talk about in this kind of book club is our process of writing. I mean, how we wrote this book, because we have a very unique way of actually writing a book, which actually is all of Neal's ideas. I just stole them. But it was really cool. And I think knowing this kind of little meta background about how we went about writing this book might be kind of interesting for any of you out there who are actually reading it or kind of curious about that.
Well, this goes back to, and I end up advising a lot of new writers who, think they have a book idea and, want to talk to someone who's written a book before. I have a lot of colleagues who are like that. And they schedule these calls with me and they think I'm going to talk about, choosing publishers and, arcane things about royalties and all that, which is mostly not that interesting in detail. But what I end up talking about is something that is just never really occurred to them, is that writing a book can be an iterative process, just like designing software can be an iterative process. There are a couple of different ways you can write a book. One of them is to go to a quiet, beautiful nest and cloister yourself away from sound and noise and distractions and think deep thoughts.
That exists.
Well,
that place exists.
Only in the mythical mind of people who think that's what writers do and can afford to do that, particularly technical writers who are not writing as a full-time job. It's always an extra job. But then your best shot is you release some first draft that goes out to a limited pool of reviewers, and then you revise that and you publish it. That's really still kind of a first draft of an idea, and it's not till the second or third edition of that book, if it's successful enough, do you get a refinement of those ideas. What we realize, both in training, teaching classes, but also in writing, is you can iterate on ideas. And the first book that I did this with was Building Evolutionary Architectures, which I wrote with Rebecca Parsons and Pat Qua. We recently just did a second edition of that book. But we started with this really small seed of an idea, but then started talking about it because we realized when you do a lot of public speaking and you get over the shock of, oh no, I'm standing in front of all these people and they're all paying attention to me, and worrying about the nervousness of that, you can enter into this rarefied mental state, because when you're really trying to explain something to someone, you enter into this mental state that you can't really achieve otherwise. Yeah. You can't do that in your quiet study away from distractions and all that. There's an energy that shows up there, and it leads you to better innovations. And so the idea is that you talk about something to get insights, which gives you more to write about, which gives you more to talk about, which gives you more insights. And before long, you've blossomed this IP, the seed, into an interesting structure. And that's exactly less with the fundamentals book, because that was really more of a kind of a filtering process of too much material out in the world. Yeah. How do you refine it? But the hard parts book was very much this idea of the vastness of hard problems in software architecture. Which are the things that we're going to tie together that make sense and are all uniformly difficult. Yeah. And distributed architecture, it turns out, was the perfect candidate for that, because just about everything you do in distributed architectures is difficult.
That's right. All right. So now, Neal, you made me go on my little soapbox. So, like in Scrum, one of the foundational aspects of Scrum is that feedback loop. I mean, this is, whether Scrum or Agile, it's all about that feedback loop. And we have found since, the early 90s, I guess, late 90s, 2000 was the manifesto, I believe, right? But and then Scrum came around. But so we have learned for over 2 decades that feedback loop in developing software is kind of the secret sauce. That's how we actually get effective software written. And we all see that and we all agree with it. But then we don't apply that same concept to all other areas of what we do, which is what, like Neal, like what you were just talking about with having that feedback loop. Can you imagine if Neal and I spent 2 weeks hidden away in some dark cave and we wrote the hard parts book and then published it? Well, what you are seeing is the very, very, very first rough draft that no one has seen before. There's no feedback loop. And what Neal's process, which I just loved and it really worked, was to say, no, let's not write the book yet. Let's find out what we want to write about. And that was just pure magic. And that's how we structured both of these books, really, and especially the hard parts book. But all right, so just a quick 1-minute tangent about feedbacks, because I want to give you another great example of how valuable this whole feedback loop process is. I'm sure, I can't ask all of you, but I'm sure all of you get performance reviews. Yeah, sure. How often are those? Every 6 months? Every year? Here's an effective way to change your career, because it's the same kind of thing as writing a book or developing software, because you get that feedback loop 6 months to a year. And can you imagine once a year your performance review? And it's like, well, I got to tell you, you need some improvement in this area. And what do you reply? Well, gee, if you would have told me that 12 months ago, I would have been a lot more effective this year. But now it's going to take me an entire year to be more effective because you just told me my feedback, either good or bad. These are examples of how we write the books now, all of our books that we've been writing. And wow, it works great. So just a little meta kind of story there.
Well, that's one of the sort of accidental benefits of pair programming, because you get much faster feedback on how things are going. But a great example of the way iterative design helps books is that when we first started, one of the things that we wanted to do in our fundamentals book was do a real apples to apples comparison between all these different architectural styles, these named topologies of architecture. Like, how do you really compare a layered monolith with a microkernel or microservices or service-oriented architecture? So we wanted to come up with a way of comparing those things. And our initial stab at that was for all these different lists of architecture characteristics like performance and scalability and elasticity, deployability, we had a binary, which was either a thumbs up or a thumbs down. And that wasn't quite enough nuance. And so then we added a third thing, which we called the Caesar thumb, which was a sideways thumb, which is neither up nor down. So that gave us 3. But that wasn't quite enough either. And we graduated to something that has become a very popular feature of our book, which are these star rating charts, which are 5 stars. You either get 1 star or 5 stars. And that is a great example of iterating on an idea and realizing it didn't have enough depth. And so we need to expand, the dimensions that we're talking about so that we have more nuance in our comparison. And we never would have really done that, until the 5th or 6th or 8th edition of the book. If we were writing it in a traditional way. But getting in front of an audience and eyes and getting that immediate feedback from an audience of, we need more nuance here, really, really helps that process.
Hey, a question I get a lot, Neal, is we talk a lot about pulling things apart, putting them back together, which you might think is only about migration, I guess. But the question I'll get a lot is, well, can I use the principles in your book, the Hard Parts book, for greenfield applications, or even maintaining distributed architectures? And of course, the answer is yes, all of those things apply. But the problem is, and here's the pushback I get on this. Yeah, but you talk about so many metrics in the book and all of these, different ways of analyzing trade-offs. Well, in a greenfield, we don't have those metrics. Sometimes we don't even have enough information for the trade-off analysis. So how do you address those kind of things?
Well, it's a great question that comes up a lot. And one of the things that we realize that you can't just write a book about difficult examples in software architecture. I mean, you could, but it would be a very unsatisfying book, because you get to the end of it and it's like, well,
that's right.
Great, just a whole bunch more things that are complicated in my world that don't actually teach me anything. And so what we want to do is do trade-off analysis between all these things. And so really what our book is a whole bunch of examples of, okay, given this complex scenario, how do you do trade-off analysis? In fact, that's the subtitle of the book, is Trade-off Analysis in Distributed Architectures. The last chapter of our book really talks about how to apply all the tools that we use throughout the book to do that. And Mark is talking about a very specific one that we end up using all the time, which is really powerful in that situation where you don't have existing a scenario, which is this, what we call qualitative versus quantitative analysis. So let's say that you have a particular workflow that you need to figure out, what's the correct way to model this workflow. If you, ultimately, ideally, what you could do is build every possible version of it. So let's say there are 8 different possibilities with what we call the 3 primal forces. Build all 8 of them and measure them in real world scenarios, and you'd know deterministically exactly which one is the best one, and then move forward. Good luck going to your boss and telling them we need 8 times as long to build something that it would normally take because we want to do this deep analysis. But the problem is nobody's ever built this thing before. So how do you know? Well, that's where we go to, that's quantitative analysis, actually building it and measuring the thing. And that's the Rolls Royce, because there's no doubt, there's no speculation in that. But you don't have the luxury of doing that a lot. So we do a lot of qualitative analysis, which is, okay, I don't know the hard numbers in this scenario, but if you look at, for example, synchronous versus asynchronous communication, I know that asynchronous communication will give me higher levels of scalability potentially than synchronous. Depending on implementation details, you can mess it up and make it worse. But, in general, from a principle standpoint, this will make it better. And that allows you to do qualitative analysis and build matrices and actually look at and narrow down candidates until you find the few that you can actually implement and, do some experiments with to see what the real measurements are. And then we encourage you, once you've actually implemented it, actually measure all those things. Mm-hmm. And this is actually a little bit of a side discussion about Building Evolution Architecture's second edition. We have an entire section of that book. So one of the things that we did after the first edition was solicit all of our coworkers and say, give us examples of how you've used these fitness functions, these ways of validating architecture characteristics in the wild. And this whole category that came back that was fascinating to us were using fitness functions as an experimental medium. Because we've never built this before. We're doing this intake from a cloud, from this mainframe, and nobody on earth has ever built this combination of technologies, and we don't know what the initial value should be. So let's take a stab at it, but immediately start measuring it and see what those are. And that qualitative analysis gets you to that first stab, but then you immediately need to start measuring it to make sure, because it turns out that in many cases, we underestimated by a lot because of some factor we didn't take into account. So it's really good to use this as a way to gradually get to more and more concrete engineering-like measures.
Hey, you just triggered a thought in my mind, Neal. You know what would be kind of fun to talk about? Mm-hmm. Other than the structure, the Sysops Squad.
Oh, yeah.
We did a really unique thing in this book. We kind of took this idea, I guess borrowed it maybe from like the Phoenix Project and stuff, but thought this book, as we were writing it, was so abstract. And one of the challenges in any kind of technical book, especially architecture, is how to take something that's abstract and make it concrete. And so we both said, we need an example. But, when we started that out, it was kind of boring. And we thought, hey, wait a minute. Why not tell some stories? Why not have some conversations to really set the stage for every one of these abstract concepts? So let's talk about the Sysops Squad, because that was actually a unique aspect of our book that I really love. And as a matter of fact, that was fun writing those conversations, wasn't it?
And it evolved really interestingly, because we realized that, and one of the things that we said was the hard parts book could either be 120-page book, 450-page book, or 20,000-page book.
Right.
A 100-page book would be all just the abstract things, and it would be completely unreadable because there's just nothing concrete in it. The 20,000-page book would be every abstract idea taken to its logical conclusion with the combination of all the other abstract ideas. And so 20,000, and that's unreadable because nobody would ever read through all those things. And so we fell upon the 450-page version of this book, which was, and it started out just like in our fundamentals book, we wanted to sprinkle in some concrete examples to illustrate the things that we were talking about. But we realized, unlike the fundamentals book, this is not an occasional thing. This has to happen a lot because we keep talking about abstract things and trade-offs. And, trade-offs, it's okay to have matrices, but then until you see it, the real world examples of those trade-offs, it's really hard to see how they play against one another. And we started with, individual examples that were sometimes related and sometimes not. But this is where the training classes came in. Because that's where the entire idea, we like to do hands-on training classes, and we were inspired by this idea from now 15 years ago, this idea of architecture katas, which are little hands-on architecture exercises, lines and boxes and that kind of stuff for hands-on classes. And we, for a lot of the hard parts material, we want it to be to the concrete examples, we used a kata called the Sysops Squad. So you want to describe the Sysops Squad?
Yeah. So the problem kind of in all the different architecture katas, these small targeted problems, we found one that was most interesting from a distributed architecture standpoint and had some very interesting challenges and problems was in fact this architecture kata called the Sysops Squad. It's a problem ticket system for a large electronics giant. And we kind of started out with these little kind of conversations that happened. But you know what evolved through the writing of this book was to say, we should kind of have a storyline. We should actually make this a story. Mm-hmm. And in fact, we started interconnecting all these different players, all these actors, the people in the Sysops Squad, all the IT folks. And well, it took a while to realign everything because we weren't even sure of the order of the chapters. But what evolved was this really interesting story about the Sysops Squad. Every chapter starts with a conversation. Neal put in so many Easter eggs. Now, we're not going to tell you what those Easter eggs are. I still want to, but no, we want all of you to kind of try to find them. But just little kind of nuances about different aspects of those stories. But the one thing I did want to tell everybody, please read those. It's part of the story. But we drew those conversations and scenarios actually after real client experiences. Some of those meetings I was actually in. So no, you'll never be able to tell the client, but let's call it Sysops Squad. Anyways, it was such a great clever way of being able to bring in a concrete example instead of the dry piece of, okay, let's show you some abstract concepts. Let's apply it to this scenario and this scenario. No, they're all interconnected to tell a story. It's a really cool way.
Yeah, the concrete examples are not dog and cat and pony. They're actually a real working system. And we actually build an entire narrative around, okay, we have this monolithic application that's starting to show the exact kind of problems that are, in our experience, monolithic applications tend to have. And then how do you work through all of the issues of, how to pull things apart and then put them back together? So it turned out to be great fodder. And the interesting thing about actually humanizing the story, so you'll actually see a font break where the Sysops Squad starts every chapter, and then there's sometimes interspersed in the chapters to show examples. But for the first time in any of our books, Mark and I had to write dialogue, which is really, really challenging. In fact, we got a professional writer to judge our dialogue and give us some really sorely needed tips to make it more convincing and less awful. So that was
an appreciative piece about writing a technical book and the kind of voice that you write a technical book in, and then switching the voice and having to actually write prose, like an actual story, like a novel. And it's much different.
Well, and in fact, when we were writing, we would talk about, the Sysops Squad voice versus the narrator voice. And I could literally, as I was reading the prose, hear the narrator voice come in after the characters are talking, like the deep voice narrator. And we did a clever thing, since this is for a book club, a little interesting writer's hack that we ended up doing, which ended up being really taking great advantage of the platform we wrote it on. We actually wrote this, it was through O'Reilly, and they have a GitHub or Git-based, not GitHub, Git-based platform for writing books that uses AsciiDoc. And AsciiDoc has this ability to do includes. And so we had all these Sysops Squad stories interspersed throughout the book, but then we also wanted them to be an actual linear narrative with, something happens here and then something happens later here. And it was hard because some of them are interwoven within the chapters. It was hard to look at the book and just see those. And so we came up with the idea of, let's do all of the Sysops Squad stories as imports, as includes in the main text. And that allowed us to completely separate those. But the the other nice thing about that was we built a synthetic chapter, the last chapter of the book, a little bit of build code in Rake, which is my preferred build language. I wrote this that would actually just go take all the Sysops Squad stories and put them in the order that they appeared in the book as one single chapter at the end, so you could just read the Sysops story from front to back, independent of where it was within the book. And that was really cool because that helped us get the narrative and, make sure the story stitched together and made sense.
Yeah, well, especially since there were multiple authors of those dialogues, to make sure we were consistent and that the personality of each character was consistent throughout. These are things novel authors do, and they spend years and years analyzing the character's personality. Well, we didn't quite go that deep, but we did at least make sure they were consistent and accurate to the conversation, what they said, the type of way they said something. It was actually kind of fun. It was almost like we wrote a novel in a way.
And you'll definitely see that at least one of our Sysops Squad members was a fan of very, very extreme sports. And so there's a lot of little personality quirks like that interspersed to break up it also serves to break up, software architecture stuff is relentlessly abstract because it's a bunch of very complex subjects. So having a little bit of conversation and dialogue, breaks up the denseness of that in a way that I think works well in a book that abstract.
Yeah. Hey, you know what? I know it's a book club, and I know hopefully everybody's reading the book, but Neal made a really, really important discovery while writing this book. As a matter of fact, it was towards, I would say, the last 80% of the book. And it was amazing. So Neal pinged me and said, hey, you got some time for a quick Zoom call? I said, sure. So I put away everything and we hopped on a Zoom call, and Neal said, take a look at this. He said, you know how we have things like communication, whether it's sync or async? Yep, we have a whole chapter on that. Workflows, orchestration or choreography. Yeah, we have a whole chapter on that. And we've been writing all these things. And Neal said, and then kind of the coordination of things, whether we're trying to do eventual consistency or simulate atomic transactions. And I said, yep. He said, I think I've made a discovery here. He said, we treat these things as individual, but I don't think we can. And so on the Zoom call, he's sketching out this three-dimensional plane. Remember the poorly drawn three-dimensional diagram on Zoom? And he's like, take a look at this. And I'm like, oh my gosh, Neal, I think you're onto something here. So that call lasted, I don't know, an hour and a half. And then we hopped on another call the next day and the next day. And we kept refining this. And it's like, I think you're onto something here, that these three forces that we've always treated as individual things, individual decisions, Neal discovered through writing the book, they're all intertwined. And it was an amazing discovery of actually how to design distributed systems. And Neal always downplays this. I know, you always do, but I think this is just such an important discovery. But that kind of evolved through writing the book, and I think it's a significant part of it.
Well, and literally the insight that I had was we were teaching an online class, and I was listening to you describe orchestration versus choreography for, I'm guessing, the 48th or 49th or 63rd or 95th time. And, it's literally just something that was kind of going in the background, but it's something I've been thinking about a lot because we were in the middle of writing this book, and we were looking for the thing that tied the second part together because, we had all these orchestration versus choreography examples, but there was nothing that really kind of
tied it together
in a way that, created a narrative around why these things matter. Why are these contributing to the hard parts? There was nothing that kind of tied them all together. And that's when I realized that, and I think the reason this is a useful insight is that we have so long treated those things as a la carte. Oh, how do you make things faster? Oh, go from sync to async.
Make it async.
don't think anything about what other side effects that's going to have.
Other forces at play.
But those other forces are tangled up and, extract and exhibit gravity when you make a decision like that. The ball moves in places that you might not want it to in terms of some of the characteristics you're interested in. And so thinking about it, but what that really ends up doing, and this is sort of a valuable side effect of that, is that tied with this kind of qualitative analysis allows you to do a comprehensive analysis of a space like that. So if you take those three dimensions that he talked about, which are communication, consistency, and coordination, and treat them as binaries, you have 8 possible combinations.
Eight
and so we actually model all 8 of them isomorphically, as generic services, and looked at, which one has better scalability. And once you go through that exercise, it gives you a feel for what forces really are at play and how things interact with each other. For example, your observation about orchestration.
Yes.
And
the fact that you say, for example, orchestration is bad. You shouldn't use it in microservices. Well, we have ratings for, responsiveness, scalability, consistency, complexity, and coupling. And look at how bad it is. But then you look at another transactional saga that has orchestration, and it's almost all green. And there are so many of these that really, you should call this some sort of Neal's law, or you should actually do some sort of theory like Cap theorem. This is Neal's theorem. But anyways, there's so many ways that it demonstrates and proves this idea. But 2 really funny anecdotes about these transactional sagas. First of all, as Neal said, we did some isomorphic diagrams. We analyzed them. We went back and forth with all these ratings, kind of like star ratings. These are red, green bubbles. And Neal's like, we got to name these. Well, a saga is a story. The transactional saga is a story about how a request goes through your system. And so Neal said, well, these all ought to have names that have to do with stories. Wasn't that fun doing this? Okay, so we came up with one that Neal termed the horror story. It's the worst and the scariest possible story you can ever see. And here's the anecdotes. Okay, so anecdote number 1. Neal's like, well, Mark, we've got all these things. We analyze them, but we shouldn't include all these in the book because some of these are going to drop off. Like, in other words, yeah, this is a combination of all 3 of those forces, but no one would ever do these. It's like, okay. So guess what happened? Exactly 2 weeks after naming the horror story, the worst possible combination of these primal forces, what happens, Neal?
The project I was working on, the architects suggested exactly the horror story. And it is the combination of asynchronous communication, choreography, but atomic transactionality. And it's obvious how they got there because they said, okay, super high performance, super scale. So we need asynchronous, we need choreography. Oh, but the business says it needs to be transactional. Congratulations, you stumbled right into the horror story. And I explained to them how hard it was to get that right because all of the powers that you have to make that easier are gone. You don't have an orchestrator. You don't have synchronous communication. So all these bad things are happening all at the same time. And you're trying to atomically coordinate all this stuff.
Yeah.
It's just like
then your head explodes.
Exactly. And so fortunately, we talked them out of that, but it really convinced us that all of these things are legitimate patterns or anti-patterns that show up in the wild.
And that we have seen them in the wild. So it turns out that we did include all 8 of these in the book because you may stumble upon these, but it's so beautiful. If you want to see the best example, go to the epic saga that we describe in the book and take a look at this combination, atomic, synchronous, and orchestrated. Well, it's really slow. And you'll see why when you take a look at the error handling. But how do you make something faster? Asynchronous. So the best of intentions by the team says, oh yeah, this is too slow. Make it async. That'll speed it up. And it turns out that turns into what we called the fantasy fiction saga, a very complex story of world building that's really hard to believe all the way through it and even at the end. Well, it was the best intentions of making something async, but it doesn't change the responsiveness. we analyzed this and we marked it with a solid red dot. So isn't it interesting? This really, again, demonstrates this theory that none of these forces individually will make a change. It's all three of these combinations that allow you to have better responsiveness. Pure magic. It was just, in my opinion, humbly, Neal, it was the greatest discovery I think we made in that book.
You may be biased. So let's wrap things up, and we'll give you another little bit of a writerly example of one of the things that we did in the Hard Parts book. We were very careful about the prose in the Hard Parts book because we were writing it during a pandemic, and we had full control over all of the prose. And if you look at the first 14 chapters of that book, they're all either in a third person or first person, the royal we, or in third person. The last chapter of the book is the one that's called Build Your Own Trade-Off Analysis. And it's where we consolidate all the techniques that we've used to illustrate all these trade-offs throughout the book. And we purposely switched that to second person because we're trying to now directly address the reader to say, okay, now it's your turn to actually go and apply some of these things. And that really was the narrative thrust of the book, and kept it from being just a collection of difficult examples. Was ultimately it was about, as our subtitle says, a trade-off analysis, how to do trade-off analysis. And wrapping up that way was a great way to summarize that, and hopefully give you some insight into what the structure of the book is and why it exists.
That's right. And listen, you don't have to be an architect for this book. And as a matter of fact, many of the decisions a developer makes almost every day, a development team, are in this book, having to choose what kind of contract, having to choose orchestration choreography. A lot of times it's development teams that make this. So I think that's kind of cool that the audience for this book is actually pretty broad. Software developer, architect, tech lead. I go as far as to say even product ownership, because there's aspects that we talk about here of understanding why teams make certain decisions or struggle with something. So from an audience perspective, it is a pretty applicable to almost every audience.
And it really illustrates, so in our fundamentals book, we coined our 2 laws of software architecture. And the first one is that everything in software architecture is a trade-off. And that's exactly what Mark is talking about. You don't have to be an architect to face significant trade-offs and decisions that you make. But the Hard Parts book really tries to exemplify the second law, which is the why is much more important than the how. So seeing how something is implemented, okay, but understanding why you chose that and, how to make those decisions is, I think, really important. And that's really kind of what we're striving for in the Hard Parts book.
Yeah.
All right.
Awesome.
All right. Fantastic. Thanks so much for joining us. I hope you enjoyed it, and hope you get a chance to read one of our books and to come back for a future installment of the book club.
Yeah. Awesome.
Again, my name is Neal Ford.
And Mark Richards. And enjoy reading our books and have fun.
Thanks.
Subscribe to the GOTO YouTube channel now and join the experts in person or online at any upcoming GOTO conference using the promo code Book Club. Visit gotopia.tech to learn more.